Well, hello everyone. Today we're gonna look into SubD. This is a basic tutorial into knowing how to use SubD in Rhino. And so what SubD means is a subdivision surface. If we go up in here in Rhino and we go here where it says SubD tools, we're gonna see all of our subdivision tools. The thing about subdivision tools is that they're different from the other 3D type of objects that you find in Rhino. So in this case we have polysurfaces, which in this case would be this one right here. This right here is a polysurface. It's called a closed extrusion, but in reality it's a polysurface. The moment we twist it and we do something with it, now it's going to be called a polysurface, which utilizes NURBS to create these curved forms of faces. Because in reality, mathematically, it's impossible to get these surfaces. So NURBS uses a specific technique of mathematical algorithms to create these type of surfaces. The other type of things that we have is mesh tools, which in this case is literally a mesh. The mesh is the most basic type of geometry, and if we were to make it simple, where there's only one face, just like this cube, and we were to twist it, how we twisted this cube, in theory these faces are not bending how this one is bending. So these faces right here are technically broken. If we were to use it for 3D printing or something like that, it probably wouldn't work pretty well. And as you can see, they're sort of splitting the surface, right? In this case, you see how it's creating that curve, because NURBS understands when the surface is being modified. In exchange, a mesh doesn't understand that, and a mesh only knows points, faces, and edges, and normals. Normals means just to what side is looking. So in this case, they are looking outside. If we flip the normals, they will all be looking inside themselves. All right. So what's the difference between these three? Here, if you look in Rhino and you click on it, you will see that you have mesh, then you have polysurface, and then you have SubD, right? These are the three different type of surfaces of polysurfaces in Rhino, and so understanding them and working with them efficiently gives you a better grasp of everything that you can do. So in this case, we're gonna work with SubD, and SubD in theory it's a representation of a mesh, but it's just automatically being subdivided for you. If we press tab as we're looking at it, now we're gonna look at its polygonal mode, and in this case, this technically works exactly like the mesh. How I was mentioning that the faces don't really bend with how you move it. So if you look at here and you look at the face right here, the face is not really bending, but the moment I press subdivision, it creates a curve because it just starts to subdivide every polygon, and it creates a smooth version of it. So if you were to use this in Maya, you would see it showcases it clearly, how a mesh is being subdivided. But in this case, Rhino makes it its own polygon, its own type of polygon. So alright, let's move this aside and let's delete this. What we're gonna start is understanding every one of these tools and SubD tools. We're gonna start understanding every one of these tools, what they do, and specific techniques to create interesting forms. Not only interesting forms, but also these things really help you create organic type of designs for your designs for architecture and other things. It's mainly created for car design and product design, but for architecture they come pretty handy. So the first one right here is just create a single face. So all it does is you create a face, right? And you can make it a quad, or you can make it 3 sides, right? So this is 3 sides, and this is a quad, right? And if every time we're gonna press tab, we go between the subdivided form and the non-subdivided form, which is just polygons. So as you can see, the subdivided form compared to the non-subdivided form is very, very different. And one of the hardest things in SubD is understanding that difference while you're modeling. A lot of the times you want to stay in the polygonal mode to see if your mesh is not breaking, because there are times where you might do something here that looks interesting. For example, I might do something here in the mesh where I'm doing this fold and I and I make it like this, and I'm looking at it, and okay, it makes sense, it works. But the moment you put it in polygon mode, the faces are intersecting themselves. You don't want to do this. You want a clean model, and in order to do so, you need to move around the subdivided form, the polygonal form. And so, as I was saying, one of the hardest things to do in SubD is understanding that there's a huge difference between these two. And there's a way to break this, you know, in terms, everything's just being filleted and just being, all the edges are, all the corners are being rounded to their highest form possible. And as just faces, it's easy to see it, but as real polygons, it's very complicated to just sort of visualize this, right? So that's why we want to stay, when we model, we want to usually stay looking at our polygonal mode, right? So let's delete this stuff. Here we have a couple settings for this face, which is output SubD. You can also make it as a mesh, which in terms would just not change if you press tab, because it's just a mesh, it's not a SubD. At the same time, you can also make it interpolated. So as you can see, it just makes it so you can work it in a different way. Don't really use that, but you know, it's interesting. You can append it. So if you already have a SubD, let's say we do it like this, let's take this and you append it, you will append it to a form that's already there. You will have to also just make sure that you're appending it to the vertex. Actually, it's not working. And so if we make a square SubD here, right? If I do append, I'm gonna append it to this. And there you go. So you have to do it while it's in polygonal mode, so it appends to it, and now they're joined as one SubD, right? Other things we have here, we have the different type of polygon types. In this case, you have the triangle, the quad, and gon. It's good to work. It's good to maintain one of the three if you're working with polygons. From edge, this is to create something from an edge, but we don't have an edge right now. Don't really need that. This is to make sure it's in the plane that you're working at. And this is the mode to make it single or multiple faces. All right. Then we got the create SubD plane. This is just the same thing, but now you have more faces in one of the SubD, so you can decide. You can make it so it's 3 point. You can make it vertical. Make sure it's from the center around a curve, and then the count. So if you make the count like 3 by 3, now your plane will have only 3 by 3. This is a good way to start designing something, because now you have the freedom to like delete some faces, and now you're able to start modeling what you're trying to do. A good way to model in SubD is you start flat. So in these two cases, these are really good tools, because you can start flat, put an image under this, and just start tracing and start slowly creating what you're trying to do. So in this case, we can start moving and start creating this sort of snake-like thing. And so then you start to add detail in this SubD right here. And then after you have that detail that you want, then you want to start creating that depth that's necessary for your model, right? So that's a good technique. If we keep going, we have SubD cone. So just to start off with a cone. Same thing. You can change a couple of the options, and then you can change the amount of faces, which makes it very helpful. We're not gonna go through absolutely every setting, because then this video will be eternal. You have a truncated cone, which is same thing as a cone, but technically you truncate it. It's nice to make like towers and high rises, etc. You can change the settings, and then you can start modifying some things, start twisting it, doing interesting things to it. Then we go into the SubD cylinder. Pretty straightforward, just a SubD cylinder. Then sphere. Sphere is pretty good to start with, because the sphere has a specific typology that it's really useful, because it's fully, most spheres in 3D softwares, they don't have a seamless connection between the faces. In this case, you always have 4 faces, then here another 4 faces, then 4 faces, etc. If you try, for example, doing if you try doing one of the spheres in the mesh tools, for example, I don't know where it is, but I can just type sphere, right? If I mesh this, as you can see, they always end up having a different topography, so different typology, sorry. So everything on the sides, it's different than how it is on the top. It all starts compressing at the top, and this is the way it works in most 3D software. So it's really good that this one maintains that that unity between everything. So okay, now we have SubD ellipsoid, which is just a 3D ellipse. Pretty interesting. This one does have what I was mentioning before, that there's not that same face connection between everything, but it's an interesting one to work with. Then we have a torus. Torus is really interesting because you can start bending it, you can start doing many things to it, and so it's one that gives you a lot of versatility to model specific things. All right. Now, one of the things to keep in mind is the way you select is very important in SubD, because if you just select an object, you will select the whole thing, and you won't be able to change the faces and to modify it. You have to select it with Shift, Control plus Shift, and then click a face, click an edge, or click a vertex, and then you'll be able to modify them. Another way to do this is turn on your filters, which is all the way down here. I don't know if you can see it. Turn on your filter, and you'll be able to see what you're selecting, what you're not selecting. One thing I do in order to not have to press Control Shift all the time, I just turn on this right here, which is sub objects, which pretty much inverts that selection thing. So now I will have to do Control Shift to select the whole thing, and I just have to click it once to select that specific phase that I'm trying to modify. So it's very useful, but let's turn it off for now so we don't get just to show what we're gonna do. Then we have a SubD box. In this case, just a SubD box. You will see it as a sphere, but the moment you press tab, it will look like a complete box. Also, if you change the faces, let's say 10 by 10 by 10, even in the subdivision form, you will see that it's a cube, right? Now we get into the interesting ones, which are the most helpful sort of commands that you can find to model things pretty quickly in SubD. These derive from the normal tools that you use in Rhino for poly surfaces, like sweep and loft and sweep 2, etc. But in this case, in SubD, they work pretty nice, and they let you create things that are really interesting. So the first one, it's create a SubD revolve. This pretty much just uses a curve. So we're gonna start with a curve, right? Whatever a curve is, we're gonna flip it, move it up a little bit, and what SubD revolve does is just it revolves around it, right? So the axis could be the center, whatever. Actually, it flipped it, but then as you turn it, you see that it just creates a revolution around it, right? Actually, what I was trying to get at probably would have been done better this way. So revolve, whatever, pow, and you can see how you can revolve around it. I've never really used this one, but for specific cases, this is probably really useful to create specific pieces, etc. Another really good one is sweep one, which I use a lot. The way sweep works is that it utilizes one curve to use as a shape and another curve to use as a rail. So if I, for example, create this right here, just a line, and I make this line right here, which would be the definition of the rail, and I click sweep one rail, then I have to select the rail first and then the sweep shape, and when I press enter, you will see that the shape's being swept along that curve. Now you see there's a discrepancy here between the curve and the actual form. You can always change the specific settings. So, well, first thing, you can take off the corners or not. We'll go around what this means, but yeah, you can change that. You can also adjust the segments. So if you're trying to add specific details to it, you can adjust the segments. And at the same time, the more rail segments you add in this specific axis, you will start to follow that curve. But there's a better way to get this, because one of the things about SubD is that you always want to stay as low poly as possible. So in this specific example, there's a lot of detail in specific areas, which is needed. There's high typology of forms, but in most cases, at least when I did this, I tried to maintain the least amount of faces possible, because it gives you the most freedom and the highest versatility to design, and it makes it easier, because the moment you start to add too many phases, things get too complicated and they don't work anymore. They don't look, when you try to edit something, it won't happen the way you're looking at it. So one of the things you want to do, so for example, if I were to do the sweep, right, I want to maintain this very low count of polygons, because the moment I start to increase the polygons so it fits the curve perfectly, now I'm kind of stunting myself with the design, because now I have too many faces and then it gets complicated to work. One really good tool here in SubD, and which I think it's special from Rhino, there's this, actually the very last command, which is called make curve SubD friendly. So what this will do is that every curve it touches, every curve that you apply this to, it will make it so everything that has SubD relations to it will work as good as possible. So the moment we make this curve SubD friendly, it will change it a little bit, but now you have the ability to morph it in that specific way. And what will happen is the moment you do the sweep, now we'll follow the curve perfectly with the least amount of faces. And this is very good in order to maintain low poly and in order to maintain the highest versatility to design. At the same time, the moment you create something SubD friendly, which you will see, because at the tips you have this little sort of gray dot. It's kind of invisible, but this gray dot defines when a curve is SubD friendly. If not, you can just always just press it again. You can unmake it friendly, then make it friendly again. What it does is that it just pins this last pin straight into this. It makes it a lot easier. So the moment something's SubD friendly, it doesn't matter what you do to this curve. If I extrude it, now it's a SubD. So that's pretty good if you're trying to create something. For example, if I'm creating like a floor plan of something kind of interesting, and I make it SubD friendly, right? The moment you extrude it, it will be a SubD. So that's really useful. So SubD friendly, it's a really useful command. Going on to sweep 2. Now the main difference between sweep 1 and sweep 2 is that sweep 2 utilizes 2 rails. The amount of shapes that you can use in sweep 1 and sweep 2 are infinite, so you can do many things. But for sweep 2, you're using 2 rails to define this form. So when we do sweep 1, you see you create this, right, following one curve, and the other curve is sort of dependent on what's happening here, and it's kind of random too. So you see this, it's not like the same curvature from here, so you have to edit it and whatever, and it can be a little annoying. But with sweep 2, you define the second curve, and you have to select the first rail first, second rail, then the shape, and it will create something that's following those two curves. Now, if we make these SubD friendly, it will change it a little bit, it will morph it, but then you can sort of bring back what you were trying to do. And the moment you create this sweep 2, it will follow it better. It won't be perfect. This is very extreme. It's a very extreme curve, so it won't be perfect, but it will follow at least this one pretty well. It also has to do with yeah, it's pretty much that the reason is that the curve is very extreme. So yeah, there you go. So these two tools are really useful. Now going into the third is called SubD Loft. And SubD Loft is very simple. All you have to do is you need two curves. Open or close, doesn't matter. And then all you have to do is select both and then SubD Loft. And what will it do is it will create a connection between these two and a form around it. So we can add corners, we can add creases. I will go around what creasing is. Close and open, and it only works when it's 3D. And you can adjust the segments too. So this is in order to create more detail. And at the same time, if you make it SubD friendly, and then you loft it, corner, you see that it follows the curvature perfectly. Now, one really good thing about these three tools, at least the ones that I use the most, Sweep 1, Sweep 2, and SubD Loft. I didn't use SubD Revolve as much because it's more specific. The really good thing about these is that when you start working in 3 dimensions, so let's say I have this is the loft I'm trying to follow, the sweep I'm trying to follow, and it's 3D. Make it SubD friendly. And the sweep shape is literally a square, which I can turn around and locate it better. Now I can, as you can visualize how this square is gonna form through this rail. If I do sweep 1, select rail, select sweep shape, now I can have this really interesting form, and it's done really fast. So this is something that I find extremely useful. Sometimes even depending on the amount of segments that you create, sometimes it creates even a more interesting form. So I'm looking at 3 segments and it looks better. This is more subjective. And yeah, it's very useful. And so for example, sweep 2, in this case, you can also have more versatility. We make this SubD friendly. And now the moment we create this sweep, we're gonna have something interesting is gonna happen. You can see you can start to create really cool forms just with one command. So this is the power of sweep in SubD. And at the same time, you can do SubD Loft, which is just being able to loft elements. So SubD Loft. You can select when it's 3-dimensional, when it's closed, you can select from where to where they're joining. You do it here to here, they're gonna be like twisted. It's probably better if I do it from here to here. Actually, no. From here to here. Oops. Yeah, sometimes if you mess with too much with the form, you're gonna mess up the way it connects. So let's bring it back a little bit. So yeah, let's just do this. I don't know why it's twisting it. I think it's because the arrows are different. You can flip it. Okay, yeah. So if you flip the direction of the arrow, you'll be able to. You got to make sure that these arrows are going at the same direction in order for the SubD to connect the right way. So, for example, we can start having an interesting form here. And with just one command, you start having these things. Really cool, right? Really cool. So, there you go. These are the 3 that I use the most to create interesting forms. If we get into the next ones, they're also pretty interesting. So the next one is multi-pipe. This is a really cool one, but there's one thing I really dislike about multi-pipe, which I wish there was a way to solve. So multi-pipe, all it is that you have curves, and the moment you multi-pipe them, you create a pipe around those curves. And a pipe is pretty much, yeah, this thing. And I can increase the radius like 10. Make it smooth. And you see how it just joins it at the end, right? So if I have like a join of 3 or 4 curves, and then I multi-pipe it, one thing that it will do pretty good is that it will join it at the ends and will make this smooth transition at this joint. So it's really interesting to create ideas and forms, etc. One thing what I was mentioning that I really dislike about it is that it creates the squares diagonally. Like, I wish this square was made like this. Like, everything was sort of angled perfect, because then I'll be able to edit it in whatever way I want. And it will work better. But it's kind of a pet peeve, a personal pet peeve. So that's why I don't use multi-pipe a lot, but it is pretty useful to come up with quick forms through only lines. Now we go into the creasings. The creasings are really important, and that's some of the things you see in here. So if we go into render mode, usually it's easier to see them in render mode to see how they actually work in the form. So for example, you see that here everything is smooth, but then on this here you have the crease, you have a crease right here, you have a crease right here. All of this stuff is creasing, and this is not a crease. So this use of crease and non-creasing makes a more interesting flow of surface. So all it is just, yeah, creasing and uncreasing. The main idea, if we make this sphere, make this quick sphere. The main idea with creasing is that it just brings it back to its polygonal state, right? So if I crease something like this, if I crease it, on the subdivided face, you will see how it interacts with the curvy areas. But the moment you go into the polygonal face, all you'll see is it is a thicker line to showcase it. But in reality, all it's doing, it's bringing it back to its state. So for example, the moment I, for example, make this whole thing creased, now you see that everything is trying to get back to its original state of polygonal form. And if I keep creasing things slowly, you will see that even clearer. You see that this is just trying to get back to that form. But it's nice because it interacts nicely with the curve forms. So yeah, creasing and non-creasing, really useful. Right here we have bevel mesh or SubD. All it does is just it creates a bevel on a corner area. So for example, it works backwards from what you would expect. Actually, let me make a 1 by 1 by 1 cube. So in this case, in a normal sort of polygon, the moment you bevel, you're just trying to make a curve area curvy, right? In this case, it's backwards, because the moment you add subdivisions, the moment you add a new line, like a new edge here, now I add more detail to it, so it'll corner it more, right? Because there's less amount of things to round up. So that's what I'm doing when I'm beveling. So the moment I create a bevel SubD, and I take this and I add this, you would expect that it adds more curviness, but it does on the polygonal form. But on the non-polygonal form, what it adds is less curviness. It actually brings it back to a more corner state. I can do it again and do it very, very, very small. The smaller it is, the less there is to curve. And you will see that, I mean, it's not that noticeable. But if I do, for example, for all four for edges, and I bevel it. Let's see. You will see that a lot more clear. So you see how everything just gets cornered up. So that's how it works in SubD. In the polygonal mode, you will see more curvature because now you add a bevel. But in the non-polygonal mode, you will see less curvature. It starts to edge it more, right? So if I bevel this again too, we'll do it even further. It's more sharp, you see? It's a really good tool to create sharpness in your designs without having to crease it, because sometimes you just want things that are more sharp but not creased, because creased is literally the most sharp it can be. Then we go into insert edge loop. This one is super important. It's probably one of the most important ones, because the moment you're modeling, so let's go back into the cube, right? Let's extrude it. By the way, the little ball is what extrudes things. A little ball right here. Instead of the arrow, the ball extrudes. So the moment you extrude things and you start working with your form and you start moving things around, there are times where you want to create that sharpness in your curves, in your blobs, whatever it is that you're doing. So the best way to do so is to add an edge loop, right? So the way edge loop works, it just, when you click it, you can select an edge loop. So this right here is an edge loop. It's a looping edge because they connect through all sizes, through all sides. The moment you select it and you click enter, now you can add an extra one, which creates this sort of, which adds detail pretty much. And when you add detail, you add more sharpness into your form. And if you look at it in polygonal mode, all it's doing is just adding a new curve. So at the same time, a faster way to select your edge loops, you can always just utilize the command and then you can select an edge loop, but you also can, instead of selecting just one edge loop, the moment you double click it, you select the whole edge loop. So if you click it once, just an edge, twice, edge loop. And same with faces. One, just the face, twice, selecting the second one, you get a whole face loop. So the way the edge loop works, it works with edge loops and edge rings. So for example, let me make a couple edge loops here. So in this case, this is an edge. These are edge loops, but then you have edge rings. So the moment you select an edge ring, this right here is the edge ring. It's what's going around the whole thing as a ring through the edges. So this also works to create your edges, your edge loops, because now you'll make it on the other axis. All right. At the same time, you have more different things. Well, you can select if it's ring or loop, but it doesn't matter because if you select it already here, it will work. And you can make it mode as a range or as just the full loop, right? So that one's really useful. Edge loop is really important. Now we go into point mesh or SubD. What this does is it just creates points, and it adds quality to your meshes. So for example, I'm creating a SubD right here, and I'm adding things, whatever. If I want to, for example, break this in half, or create or connect this to this and have a triangle and a square, the way I do it is with this command. So it's insert point to mesh or SubD. It works in a mesh and it works in a SubD, as it says there. But in a SubD, you see now you're able to insert a point. So one important thing is that you have your OSnap enabled, which you can click here and just enable your OSnap. So it will snap to the vertices, vertices, and to your edges, to the middle points, etc. The way I do it is I always keep it disabled because I like the freedom of putting things wherever I want, and then I just press Alt to snap it, because what Alt does, it just automatically enables OSnap. You see it here. But let's disable it now, just so we can work better. So if I connect to, you want to make sure that when you make an edge loop, you connect it to a vertex. The moment you connect it to a vertex, now this right here will be a triangle, and this right here is still a quad. So now I can add an extra edge loop from here. and one from here. So there are many use cases for that, but you wanna make use of it to add detail to your models. So then we have append faces to SubD. This is an interesting one. For example, if we have a plane here, then let's say we delete this one. There are many ways to sort of fill up this empty hole right here. There's many ways to do it actually. But one way is to append faces. If there's always many modes, but sometimes these modes don't work. The more complex your form starts to get, you will start to see that the things that you thought worked to create, to fill up faces, to fix things, etc., sometimes they don't work. So you want to always use those plan Bs. Append faces, all it does is you just append a face to a SubD. So in this case, I can just create a face, and then it appends it, but I have to do it better. So it actually appends it. There you go. So now it's appended. And same thing, if I want to do here, I just click to these 4 points, and it starts appending the face until it closes it. Oh, okay, I missed that one. I mean, you always want to work in the polygonal mode. I'm doing this so you can visualize it, but yeah. So that's one way to do it. Append faces, all it does is append faces. It's pretty straightforward. Yep. Then we have merge to coplanar faces. This all it does is just, as the name says, it merges two coplanar faces. Actually, these won't merge. They have to be coplanar. So what that means is that they have to be the same plane. So the moment I do this, and I just merge them, see, it merges the faces, and now I can sort of do different things. Pretty straightforward. Then we have inset SubD edges. What this does is that the word says just insets SubD edges. So I'm gonna inset an edge into this form, into this specific face, which can be very crazy right now. But we make it 1. You see how it's much nicer. And this works pretty well to create these like holes. So all it is like an offset for a face. We do inset SubD edges, and we give it a distance of like 5. You see that it's just subsetting it inside. We can start cutting it. We can start getting interesting things. Pretty useful. But there's nothing else to it. It's literally just that. Then we get into stitching. Stitching is also really important because, for example, if I have 2 SubDs and I want to join them, there's many ways to do this too. So if you have 2 SubDs, you want to join them, you can always loft them. Well, not lofting them because that won't join them. But one thing you can do is stitch it. So you can stitch an edge together. Actually, you can stitch a set of edges, but the way I do it is I just stitch vertex. You see that I just stitch in vertex with another vertex, and now I have a combined face. One thing about stitching is that if something is creased, the moment you stitch it, you're gonna have to uncrease it and crease it again. So here I have to uncrease it and then crease it again. Well, in this case, it maintains that, but in other cases, you're gonna have to uncrease it and crease it in order to actually make it work. So for example, here, if I have these, this is not the conventional way to do it, but if I connect these, right, if I stitch it, and let's say I have this whole loop creased, right, and I keep stitching them, you're gonna see that the stitch, sort of the edge loop, the creasing in this edge works pretty weird because it's just being stitched. So what you have to do is uncrease this, and then you crease it again with those loops that you were creasing, and now you will have that curvature that you were probably expecting to have. So it's one thing to really make sure you do when you stitch. That's why it's so important to switch between polygonal and non-polygonal mode, which is called flat to smooth. So that's probably a better way to call it, flat to smooth. Same way, actually, let me keep this one. The one we go to next is bridge, meshes or SubD. This is like an amazing one because you can bridge SubDs together. So if the faces that you're bridging, the things that you're bridging have the same amount of points, same amount of edges, they will bridge. It will work. So you just click it, and there you go. You have a bridge. You press tab, you see how they join. And same way, you can add more segments to it. You can also crease it at the ends. You can also change the straightness, which is just how much it opens. It's really useful, and at the same time it works with singular faces. I can just bridge this. Actually, you just bridge these two, and now I have just a bridge of these two. And you can always bridge things together as long as they have the same amount of faces. Pretty good. Moving on, we have subdivide, SubD. You can keep this the old examples. All this does is just it takes a face, or it takes the whole SubD and it subdivides it even further to add detail, right? So for example, if I were to do that on this one, it might be a mess, but it just takes you closer to that subdivided form that you already had. And now you're able to add more details that maybe you were thinking about adding before. But I don't like to do that, at least on this, because there's no more detail I need to add on this. But if, for example, these are not enough polygons and I just need more, I can just add more. And at the same time, I can also do it on singular faces. So if I want more faces only here, there you go, I subdivided, and now I can edit that specifically, right? It's pretty useful. And same, it works on meshes too. This is just to slide edges and vertices. This doesn't add a new vertice or a new edge, it just slides it. So if I take this edge and I make slide, all it's gonna do is slide it and move it around. It's gonna move it around the geometry that I'm doing, and it probably works better. There's probably a better way to look at it with the cube. If I make the cube and I do this, if I want to slide this around, I can do it up and down, but if this wasn't a weird angle, right? I cannot just do it up and down. I mean, I can technically if I just orient it to the shape, which is not working, but fine. But yeah, you can always just slide it. So you can slide the mesh on the geometry that you're working on, right? It's pretty helpful. You can change the direction to across or along, which along is pretty weird in this example. You can make it smooth or not smooth. I'm not sure why it's that. Yeah. And you can make the offset proportional, absolute, whatever that does. But yes, there you go. So it's just to slide things across. You can also slide vertices, which is not working pretty well here. I'm sure there's specific use cases for the vertices, but I never use that. So yeah. Then we have the pack SubD faces and set SubD faces set by color pack. This is one that I don't use either, but it's useful when you're trying to 3D model, and this is used a lot on softwares like ZBrush and Blender and all these ones, where you need to understand how things are being unpacked in NURBS. So if you're trying to convert this into NURBS, the moment you click the set SubD per face by face pack, you have to first pack SubD faces and then click this, and you'll see it. All this is showcasing is what the faces that are going to turn into NURBS. So for example, this color right here, this is going to be one NURB, one geometry that has its own sort of calculation. And same with this. So the moment you move it around, I'm not sure how it works, but the moment you move it around and you pack it again, should change. There should be a way to change it, but this is just to visualize it. It's only to visualize how these NURBs will be created the moment you unpack it, right? But never really use that. Here, right here, you have merge faces, which it just merges the faces. So here, I mean, it's the same as coplanar, but it doesn't have to be coplanar. So it might work weird at times, because if things are not coplanar, let's see. I move this around. I merge faces. It's a better coplanar merge, I guess. So it just merges things without having to worry about coplanars. But yes, here we have delete faces. This all it does is just, as it says, delete faces. But you can always just select and delete at the same time. Here we have reflect SubD. This one's very interesting because let's use this one as an example. Sometimes you want to create symmetry and you don't need to work on both sides, right? So all you have to do is select your shape, find that axis point that you're trying to use, and then just create that symmetry. In this case, you get something really cool. Looks kind of like a plane. And the moment you start editing things on one side, they will animate the other side. Now, in order to take it out, all you have to do is select the SubD and then right click to remove the symmetry. And now there's no more symmetry, and you can start working on just one side. It's really useful when you want to create nice symmetric forms, or at least the preliminary form of your design. They have radiate SubD. It's also very useful, but it's complicated to use sometimes. So for example, I have a cube and I want to create it in sort of a polar array instead of a symmetric array. I can just click radiate SubD. I can do 3 segments and then select the midpoint, and then it merges them. In this case, they're not joining because they're very simple forms, but they will work together at the same time. So I can just work around with these. We can try with this, see how it looks. So radiate SubD. How? And there you go. It works pretty weird. And so then whatever you do, it will animate. The same time you can select SubDs, you can select specific face. So it works pretty good. And then you get into SubD fill hole. This is one of the other ways where you can fix things, like I was mentioning before. Or for example, if you have something that's gone, a hole, you can just fill it. So if you just select the edges, select fill hole, it will fill it up. And it's back to its state. So that works pretty good just to start fixing things around. Then we have extrude SubD. Let's use this as an example again. For extrude SubD, it's pretty straightforward. You're extruding a specific face, right? Which you can also do with the gumball by just pressing the ball. But one thing that's special of extrude SubD is that you can select an entire ring of faces, an entire loop of faces, and extrude them all together. You can create interesting forms. And at the same time, you can change the direction where they're being extruded. In this case, they're all being extruded tangent to their specific face, but you can change the direction to be free. It can be free to like whatever position you want it, and you can change the basis to like a specific axis. So I can do it to like the z-axis, but that never really works. So yeah. Then we have offset SubD, which this one is also pretty useful to add thickness to your SubD. So if, for example, I'm working on something and it's still just a plane, right? So I'm creating my SubD and I start to create this flat form that I was mentioning too, that you're just following things. In order to add thickness to it, you can just do offset SubD. It will show you the arrows towards where it's offsetting. You can also change the distance of how much it's gonna offset, and you can make sure with if it's solid, if it's both sides, and if it's gonna delete the input. You can flip it here too. Usually, you want to keep the solidness, so it just creates the solidness you're looking for. But at the same time, you can also just offset it by not doing solid, and it just moves it up. So to make it more visible, yeah, it just moves it up. But if you add solid, it will make it thick, which is very useful for your designs. Now we have quad remesh. This one's pretty useful if you're working with other type of 3D geometries. So in this case, if I have a, let's say, a weird mesh, let's use this square. Actually, let me make a 10 by 10 by 10 mesh cube, and if I start to cage edit it, this is just if you have a weird geometry. In this case, I'm just gonna like twist it around, move it around, and destroy the typology pretty much. And I have to do the cage edit because meshes don't really work without it. So the moment I quad remesh this, it will find a more sort of, well, I can triangulate it first, right? So what quad remesh will do is it will create quads, and it will make the most efficient form of remeshing it, which comes pretty handy because it also, you can make it a SubD. It works as making it a SubD and also as not making it a SubD. And you can change the amount of quads you want. You can change if it's adaptive. You can add symmetry. You can use curves to guide it, curve of influences. You can preview it. It'll take a minute to preview it, but then when you click OK, you can look at it and you see how it remeshes something that was maybe really complex. And you can start working with this as a SubD. It's a really useful command, but be careful with when you have really big meshes and you're trying to create a lot of faces, because it can crash your computer pretty easily. This one right here is just repair SubD. Whenever there's flaws in your SubD or something, this one has no flaws. But whenever you work a lot with a project and you have a lot of different phases, things can get a little complicated. So you might want to press repair, and it might fix a couple things that you're not aware of, such as like faces that are missing, flipped faces, curves that are intersecting, etc. This is just to convert things to NURBS. So for example, how I was mentioning before with the packing faces, the moment I convert it into NURBS, right, and I delete the object, which NURBS is just a polygon surface, you will see that every face, right, it's being unpacked from the color, right? The things are unpacked, defining by that color before as specific surfaces for as NURBS. Oops, I might have done something here. I'm gonna cancel it because it's a very complex geometry, so it might take a lot to calculate it. And vice versa, you can create anything into SubD. But that it's complicated sometimes because it might not work pretty well. So if I have an extrusion and I want to make it into SubD, just click make it to SubD. I can crease it, create corners, and I can delete the input. But at times, you know, it doesn't, from poly surfaces, it doesn't really understand it pretty well. But it's an interesting way to get forms from other forms by making it into a SubD. This right here is just the toggle display, which is tab. You never really want to click it, you just press tab, and it makes it a lot faster. And this right here is only to select SubD objects. So if you have a model with SubD object with meshes with a lot of different things, then you might just want to click this and you'll see which are SubD objects. Same thing here, you can select an edge loop. This is just the commands that I mentioned before, so if I just double click it, I can do that. But at the same time, I can just click here and it will select the edge loop for me, right? Same thing, you can do select the edge ring. So you can click on select edge ring and it will select the whole ring that's wrapping around that set of faces. And same thing for faces. Select edges, this one, where you can select the entire thing even with the faces, so you can edit it. This right here is the select by brushing, which you just sort of brush around. Actually, you have to turn on the sub objects, and the moment you brush around, you will select those faces that you're brushing through. It's not really useful. I don't use it in that much, but it can have its use cases. You can make it so the selection mode is crossing, invert, or by the window that you select. It works kind of strange, honestly, but yeah, you can do by crossing. You can make it so it doesn't select through objects. You can increase the width of whatever brush you're using, and do 3, and there you go. You can just brush around and select faces. So it can be useful. You just want to find the specific use case for it. These last things right here, this is just a filter. So if I click on this one, it'll filter only the edges. So whenever I'm working on it and I have sub objects activated, it doesn't matter where I click, I will always select edges, only edges, which can make it useful if it's a complicated model and it's hard to click specific things sometimes. Same thing with faces and vertices. Every software has these 3. You can also create shortcuts for these. I have them as Control 1, Control 2, and Control 3. But honestly, I find it better just selecting everything, because Rhino works pretty good and it lets you select things pretty good. So here's just, you can just erase that selection filter so everything comes back, and here you can invert. So if I have faces, then I can just toggle between if I have edges, you can toggle between vertex, selecting vertex, selecting faces. I don't know, it's not working. Edge, vertex, selection, whatever. But yeah, you can click this one to go back to everything and select everything, so you don't have to click back to every single box. The last thing about SubD that I want to mention, which is really, really useful if you're creating very, very complex and big models, is this right here, which is name selection panels. The moment you open it up, is a new panel. And what you do here is that you can start selecting faces in SubD, specific faces, specific corners, specific edges, and you can save these selections. So I can save this right here and call it selection 1, S1, right? And so then I can keep on modeling whatever I'm modeling, doing changes, making changes and whatever, and things move around, whatever. I'm just messing it up. And if I want to go back to those 3 faces that I was selected before, I can just click here and it'll always bring me back to those faces. So it's really useful when you're creating very complex things. And for example, you have an edge loop which you don't want to lose. The moment you add more stuff, you might lose that edge loop, so you want to save it as a selection. Same thing with edges and vertices. And when you have very tedious things to select that are not edge loops, that even if you try to do edge loop, it won't click it, and you have to manually select one by one, you can do that and then save it. So if you want to edit it again, you don't have to open it again. But yeah, that's it for this tutorial. The second part, we will go through how to create something more like this, where you exploit your creativity. Hope you guys like this video. Subscribe, follow, and thank you.